Here's Algebra 2, Lesson 117. This is your video lecture. So, this stuff, it's all words, no numbers, huh? So basically we're learning some things about statistics and probability and different ways of gathering data. What this lesson is just about recognizing misleading data. So sometimes in an effort to, make your product look good or to try to prove something, that you want to prove, a person might skew some data to make it something look like what it's really not. So there's different ways you can do that. Sometimes just by the people that you ask, like let's say that you want to let's say that you really want football to be the #1 sport at your school. And so if you want to prove that everybody wants football to be the #1 sport at your school, maybe you could ask, you could take a poll, and then you could say, see, everybody wants it to be the #1 sport. But the way that you take a poll, if you go to a football game and ask football fans when you take your poll, of course they're going to say they like football the best, right? So it's kind of like by the people that you ask or by the data that you collect, you can kind of steer the outcome to be what you want. You can mislead people, basically. And so that's kind of that's one way that something can be misleading, is just by the people that you ask or the time of year that you ask. I'm not going to go through every example because I think you can go ahead and read them. Sometimes you won't sometimes a survey won't give you the option that you really want. You could have a survey and it would say, what's your favorite food? And then it just gives hamburgers, hot dogs, and corn dogs or something. Well, I guess you could pick out of those three, but it didn't give you enough options to find out what if they wanted to know what's Americans' favorite food. They only give you these narrow options. So so that's kind of what this one is. The way that they question you might kind of skew your results. The kind of answers, the kind of if they gave you A, B, and C multiple choice, then you don't have a chance to put what you really feel because you only had these three choices and none of them were your favorite choice. So that's kind of what this is about. So that's one way. Another way you could have misleading data. The displays is the one I think is funny. And this happens all the time. They'll have maybe some good information that's true, but then the way that they display it on their graph, they want to make it, look a certain way. Like these, it looks like this one is so much more than this one, but if you look at the numbers, see they cut the bottom off. So really this would go way down. That's 66 right there. This would go way, way, way down. And then if they showed this whole graph, these wouldn't look so far apart. It wouldn't look like this one's 3 times, or is it 3 times bigger? It wouldn't look so much bigger than that one. But when they lop off the bottom, it just changes the appearance of the graph, and it makes people likely to say, wow, that one's way far and above this one, when it's not really. It's only, what's that, 76, and that's 66 or something. So it's not that far in the grand scheme of things. I mean, if you could see the whole bar graph, you'd see that it's not 3 times bigger. It's only a little bit bigger. They chopped off the scale and made it look like something that it might not be. So that's kind of the gist of what we're learning. So letter A says a salesperson for a new lotion. A salesperson for a new lotion gave samples of the lotion to 4 dermatologists, only 4, and asked them if they would recommend it to their patients. 3 of the dermatologists said they would. The salesperson wrote a brochure stating that 3 out of 4 dermatologists recommend the lotion. Why is it misleading? Well, it's true. It's not that the person is telling you a lie, but they're misleading you, because if I read that in a brochure, 3 out of 4 dermatologists, I would think like 75% of all dermatologists, you know, or of a large number of dermatologists are recommending this lotion, but it turns out it's just 3 of the people that she gave it to, or whoever the person is. 3 of the people decided to recommend it and 1 didn't. So it's misleading, because it makes you think that like a lot of dermatologists are using this lotion just because of the small sample size. So you could say, why is it misleading? I'm not even going to write this down. You can get out your pencil and write it down. Why is it misleading? Because of the small sample size. That's all you have to write, because of the small sample size. That's letter A. Letter B. A student wants to know the average height difference between boys and girls in 11th grade. In 11th grade homerooms, the student walks up and down the rows asking other students to state their height in inches. How can the result of this survey be misleading? Well, first I was thinking, well, did they go to the wrong place? Are they asking the wrong people? But I think that they went to the right place. If they just went to all the homerooms, then they'd have a nice mix of 11th graders. So I don't see a problem with that. I think the problem is that when you ask someone their own height rather than weighing them, or measuring them, they might round the numbers up or down. They might not really actually know how tall they are, so maybe they'll tell you a number that they think might be close, but it's not, and so that's going to skew your results. They might want to say that they're a little, maybe they want to be taller, and they'll say that they're a little bit taller because they're being asked right out loud in front of their peers. So it's kind of, when you ask someone, like if they actually were to measure them, that would give some better results than just taking someone's word for how tall they are. So what should you write for your answer? Write results might be inaccurate because people tend to round numbers, or they might not know their height. Okay? So you can write it on your own. I'm not going to write all these down. Explain how this graph could be misleading. This graph is funny to me because, like, here's a little balloon and here's a big balloon, and so the little balloon, it looks like it lines up with 30. It lines up with 30, and then the big balloon lines up with 60. I have to leave, so you have to wait. I have to bring that back there. The big balloon lines up with 60, and so the difference between the balloons is that the big balloon is twice as big as the little balloon, if you look at the numbers, right? But if you look at how big this balloon looks like the area of it looks like it's like 4 times as big as that balloon, so that's misleading. Okay, and then the last one, because I'm running out of time, the last one, a study showed that individuals who visit a dentist twice a year tend to make more money than individuals who visit less than twice a year. Can it be concluded that a dentist causes a person to make more money? I doubt it. Let's just say that association is not causation. So your answer, you're going to write down association is not causation. Okay, sorry, I ran out of time, or I'll explain that more.